Hello, my name is Kyle Shett. I will be presenting the Smart Route application that we created. We created this application along with Wei and Pereng for the CS6604 course project. As we've discussed in the presentation so far, this application allows users to enter in an origin and a destination and points of interest, and will automatically determine the least costly route from one to the other while visiting the point of interest in question. So with that, I'll go ahead and get started right away. We'll just go ahead and launch the Smart Route application. It's a very simple application. As you can see, I'll just minimize the keyboard for a second so we can look at this. We have your origin, the point of interest that you wish to visit, where you want to go, a route button to go ahead and execute the fetching of this particular route, the steps, which is a step-by-step instructions on how to go about navigating through this particular route, and then obviously the Google map here at the bottom. We designed all of this in Google's Android platform, and we have a back-end Python server that helps us do the calculations with and communications with Google's APIs, with the WMATA APIs, and also implementing Pereng's algorithm for determining the least costly route. So with that, I'll just go ahead and get started. We'll do a quick one right here of saying, let's just say, we're nearby at the Northern Virginia Research Center of Virginia Tech, right near the Glebe Road, and maybe we're done with the day and we want to go and find a gym somewhere before we have to head to class. So we'll go ahead and just enter in gym, and then we gotta go to class. So we have to head out to West Falls Church. We'll go ahead and enter in that address. We can see that this already does autocomplete and populates based on what you're typing, kind of help you out. And so I'll go ahead and select where the West Falls Church campus is. And we'll go ahead and click Route. Hides the keyboard, and it's going off to the server now and requesting all the information about the origin and the destination, the routing information that we can get from this. And also looking for points of interest. And what it's trying to do in the background is determine, obviously, the least costly of these routes. So we'll go ahead and see that this is zoomed to the extent that we needed to. This is our destination right here at the Northern Virginia Center, and we can see over here this is the gym that it found. We go ahead and scroll in. Our starting point's way over here. And the green indicates that it's walking, and buses are blue, and obviously walking is green. And then each of the subway or each of the metro lines are then colored appropriately based on where they're at. So we'll see we have to take the orange line here. This is kind of an interesting result that we got from this one. So starting over here nearby the Virginia Research Center, it's telling us to walk to then catch a bus all the way to our destination. We go to the gym, hang out for a little bit, do what we need to do, and start walking back to the metro, hop on the orange line, and then take the orange line all the way out. Maybe another scenario that we can look at is maybe something a little bit farther away from the Northern Virginia Center. Let's say I'm coming from home over in Alexandria, so I'll just go ahead and enter in Mount Vernon Avenue. And yeah, I'm pretty hungry, so I'm going to want to go to the Green Turtle. It's actually right by campus too. Well, let's do something a little bit more generic. Let's say, no, let's go to the Green Turtle. We'll do a generic one here in a second. Green Turtle. Yep, and then go into class. So I'll go ahead and click Route. We'll let it go off and see what it finds for us. This one's going to be looking for specific landmarks based on the name of the restaurant. So there we go. It comes back. So the Green Turtle. Here's the Green Turtle right there in Arlington. Note this is expected. So this is my typical route going to the Northern Virginia Center if I need to on Metro. Otherwise, I just drive. But we can see that from my house, I have to get on the blue line. Take the blue line to Roslyn, change trains, get on the orange, come all the way to Ballston, and get off, walk to Green Turtle, walk back, get back on the Orange Line and go. You can look at the steps too for this. You can see like walk to King Street Metro, take the subway to Largo Town Center, then get off, take the subway to Vienna, and here we are arriving at the Green Turtle after we're walking. Then get back on the subway towards Vienna and go all the way back to our destination. Let's go ahead and clear all this out as well. And let's say I want to come home from class and I'm still hungry even after the Green Turtle. Say I want to let's just go to a grocery store. See where along my route home would be the least costly place to go to the grocery store. And let me just flip I'll go back to my house. Let's see where it thinks the least costly grocery store is for me. I'll let it think for a second. And what it's trying to do is calculate all the different stops along all the routes to determine which point of interest is actually closest to the route so that it's least costly when it comes to walking, because it's more time consuming to walk than it is to take the bus or the metro rail. So here we go. So here we are starting all the way up here at the Northern Virginia Center. On the Orange Line, follow the Orange Line, and it says that the grocery store is right here off of North Fairfax. It's right next to the Virginia Square Metro. Well, that seems really convenient since I know that there's no grocery stores really nearby to my house, so that'd be great. Just hop off there, get my groceries, hop back on, go to Roslyn, get on the Blue Line, come all the way home, and then get off the King Street Metro and walk right home. Well, that has been a demonstration of our application. If you have any comments, please feel free to contact one of us. If not, thank you.